Hi guys, and welcome to another exciting edition of Worms Maths Academy doing a Maths Methods exam. So this is Methods Exam 2 2017, and I'm just going to do the multiple choice and then I'll do the extended response soon. I actually don't even recall doing this exam last year. I must have been too busy. So let's have a crack. Okay, so 5 sine 2x minus 1. The period one, we know the period is 2 pi on n. In this case, n is 2, so our period's pi. So I can automatically scrap those. My range, my center of my graph is -1. And I've got to add the amplitude and subtract the amplitude. So we're going to go up to 4 and, oh, I wrote that. -5, which would make it -6 to 4, which means that C is our answer. Okay, part of the cubic equation of f, and the coordinates of the stationary points are shown below. F dash x, the gradient, is less than 0, negative. So it's going to be from here to here. I shouldn't have coloured in those points because it doesn't say equal to 0, it just says less than 0. So it's from x values, remember, -3 to 5 on 3, not including the endpoints. A box contains 5 red marbles, 3 yellow marbles. 2 marbles are drawn at random from the box without replacement. Probably the marbles are different colours. So we could get a red, then a yellow, or we could get a yellow, then a red. A red is 5 on 8 times, I've got 3 yellows left, and there's 7. I could get a yellow, 3 out of 8, times 5 reds left on 7. So we get 15 on 56, 15 on 56, 30 on 56, 15 on 28, which is there. CDC so far. Okay, let f and g be functions such that g of f of 2 is 5, f of 3 is 4, g of 2 is 5, g of 3 is 2, g of 4 is 1. Okay, the value of g, f of g of 3. Okay, so we want f of g of 3, but we know g of 3 is 2. So therefore, we want f of 2, because we know that g of 3 is 2, which is 5. It's a nice and easy one. I bet you quite a few kids got confused by it though. Okay, 95% confidence with the proportion of ferry tickets that are cancelled on the intended departure day is calculated from a large sample to be that. The sample proportion of which this interval is so what's a proportion? Okay, if I've got 0.039, that's one end, and I've got 0.121, that's the other end. It's going to be halfway between those. So if we add them together, we get 160, so it's going to be 0.08, which is A. There's another nice and easy one. Well, I think it is. Okay, part of the graph is shown before. The same scale is used on both axes. That's always a good idea. Inverse function. So we just got to reflect it. Okay, so easier said than done. Like that. Looks like C to me. There's nothing else that even looks close to it. So 6C. No, I missed a question. The equation that has no real roots when, okay, no real roots with a quadratic. So we're going to have p minus 1 x squared plus 4x. And then plus p minus 5, because when I bring it over, it's going to change sign. Now we know the discriminant has to be less than 0 because I want no real roots. So b squared, 16, minus 4 times p minus 1 times p minus 5 has to be less than 0. Okay, 16 minus, don't forget you can use your calculator. So here, 16 minus 4, p minus 1, I mean, I actually think it's quicker just in this case to do it p squared minus 6p and then plus 5. The good thing is with the calculator, it reduces the risk of error. So minus 4p squared plus 24p plus minus 20 is less than 0. Okay, if we divide through by negative 4, we're going to get p squared. That's going to change to be greater than 0 because I'm dividing by a negative. 16 minus 20. If I divide that negative 4 by negative 4, I get plus 1. And if I divide 24p, I get negative 6p plus 1 is greater than 0. So p squared minus 6p plus 1 is greater than 0. So we get B. Could have used it on your calc as well. Okay, A is greater than 0, then it's equal to, so x is equal to, okay. So we're going to get y minus 2 log A of y, because to get rid of that, we've got to log the other side, is equal to b minus 4x. We get 1 on b, log A, y minus 2. I can't believe I just did that. Okay, so what I would do in this case, I would bring 4x to the other side, so 4x equals to b minus log A of y minus 2, and then I'll get x is, that 1/4 is multiplying everything, so 1/4 b minus log A of y minus 2, b minus log A of y minus 2, so we get A, number 8. The average rate of change, x squared minus 2x, from 1 to A, where A is greater than 1, is 8. So we know f of, let's define x squared minus 2x. X squared minus 2x. Just quickly define it. Okay, we know f of f of 1 minus f of y is on 1 minus y is equal to, was it 8? 8. Interactive advanced solve for y. So y is 9. Remember, average rate of change is just the gradient between 2 points, which is what I just used. Okay, so we've got this graph. That's a dilation of 2 from the y-axis, which is f of x on 2. So wherever I've got an x, I've got to replace it with a 2. So I get y equals, oh, this is another one that you could define and then just do these transformations in your CAS. What I mean is 3 sine 2x plus pi and 4. 3 sine, make sure your calculator's in radians as well. 3 sine 2x plus pi divided by 4. Define. Let's make sure it's the same. Okay, so if we want, that is a dilation, it's f of x on 2, and then if I put a third out the front, because it's a dilation of a third from the x-axis. So if I did 1, so 1 on 3, f of x divided by 2, simplify, says cos x, which is what it is. If you had to do that by hand, you might not have been able to do that, but your CAS just spits out your answer. Okay, the function that has a local maximum, i.e. dy dx equals 0, and a local min, another one, dy dx equals 0. Okay, the values of a and b respectively are, so let's quickly define it, x cubed plus ax squared. X cubed plus, I'm going to use a times x squared plus, I'm guessing it's b times x, define. I always type it again to make sure nothing's defined, which it's not. Let's just check and make sure I did it right. Yep. Okay, so we want to solve a simultaneous equation. Actually, what's easiest is to go d dx of f of x. So that's my derivative. Define that as g of x. Now we've got to solve the simultaneous equation. G of -1 and 3. -1 equals 0. G of 3 equals 0. And then we want to solve for A and B. -3, -9. D. Okay, that looks pretty good. What are we up to? 12. Okay, the sum of those solutions. So sine 2x from -pi to d is, I'm just going to do it on the cuz as well. So sine 2x is equal to root 3 divided by 2. I'm going to solve it. It's going to give me a general solution, but I'm going to say from given -pi, because that's what it's from, is less than or equal to x, which is less than or equal to 3 pi on 2. That's the greatest value there. So let's do 3 pi on 2. 3 pi divided by 2. Okay, so if we do that, plus that, what has it got to equal? Pi, or -pi. Get away. Stupid thing. -pi. Is that it? I think we've got the answer. -3 pi on 2. And then if we add pi on 3, that's negative what? And then we've got to add pi on 6. But pi on 3 is bigger than pi on 6. So plus pi divided by 6. So it is pi on 3's, don't be confused by the calculator, pi on 3 is bigger than pi on 6. What? So the value of d could be, okay, but it's got to include pi on 3. So 3 pi on 4 includes pi on 3. If we did that, let's see what our solutions are. It is all of them, which when we add it, it gets to pi. So it's not exactly an endpoint, but the solution is 3 pi on 4, because we want to get, we want to make sure that we include that last answer, which is pi on 6 and pi on 3. Okay, -1 to 1, 1 on is not true. Okay, so I'm going to define one on x minus 1, define it as f of x, and then we want to, on this calculator, I think on the other calculator, you just, let's judge h of x times h of negative x. So f of x times f of negative x is equal to negative f of x squared. And we say given negative 1 is less than or equal to x, which is less than or equal to 1, or was it not equal to? Can't be equal to because it's dividing by 0. Okay, so that's true. Let's try the bottom one. H of x squared equals what are we? H of, oh, what have I done? So we know it's not that. I know if I go for the bottom one first, probably going to be the top one, but let's do it anyway. So h of x all squared. So f of x false. So that's f of x all squared is equal to f of x squared. It's false. So we know when it says not true, it's that one. You could go through and test them all. I just got lucky because usually I usually go A, B, C, that's wrong. I jump to E, then I go, oh no, it's D. No matter what, it always seems to be wrong. Okay, the variance of x is P is between 1 and 3. Okay, that's just for this sake because it's got to be, can't be negative. Okay, so E of x is negative P. That times that. Nothing times 0. Then I'm going to get plus 1 minus 3p, so it's 1 minus 4p. E of x squared is p, that's nothing, plus 1 minus 3p, which is 1 minus 2p. So e of x squared minus e of x all squared is 1 minus 2p minus 1 minus 4p squared. I'm just going to do it in the calc. 1 minus 4x minus 1, if I can remember what it is, that's a 2, minus 4x squared. Simplify your stupid thing. Negative 16p squared plus 6p. So it's got to be D. What number was that? That was 14, so 15. Okay, has vertices, lies on the graph as shown below. The maximum area of the rectangle is. Okay, so that's x. That is whatever that function is. So our rectangle area is x times negative x cubed plus 8. The maximum area of the rectangle, and it's between 0 and 2. Okay, so x times negative x cubed plus 8. Calculation f max between 0 and 2. Okay, what did it want? The maximum area. So the area is this one, 6 cube root 2, which is B. Nice and easy when you have a CAS and you know how to use it. Okay, random samples of Australians. Fortunately live in the city. 5 Australians, so n equals 5. What's P? We don't know what P is. So X is binomial 5P. If I want that 0, I've got 5 choose 0, P to the 0, 1 minus P to the power of 5. That's 1, that's 1. 1 minus P to the power of 5 has to equal 1 on 243. So I get 1 minus P is equal to, what's the fifth root of 243? It's got to be 3. What am I doing? So it's going to be 1 on 3. So P is equal to 1 minus 1/3, which is 2/3. 2/3. Okay, so we know what P is, and I want P to be greater than 0.6. So I've got 5 of them. I can't have 3 because that's 0.6. I've got to have 4 or 5. So it's binomial 5. So binom CDF, P is 2/3. We want to go from 4 to 5. We want to include both of them. 5 trials, 2 divided by 3, 0.4609. So 16 is C, assuming I haven't stuffed anything up. 17. Okay. So we've got that and that, which are the same, that and that, which are the same, but then negative. Okay. A to D. If it wants the area, then that's going to be negative, so that's no good. A to B. That's okay. C to B. That's just going to make it negative, so that's no good. 2 times A to B. That's those two. Plus B to C. That's going to be negative, so that's no good. 2 times A to B, which is going to give us that and that, minus 2 times B to B plus C. Okay, so let's say B is -1. C would have to be 1 because it's symmetrical. If I go from B to -1 plus 1 to 0, that's going to give me that area. If I times it by 2, it's going to give me both of those areas. And because that would be negative, the negative would make it positive, so it's going to be D, 17D. Okay, 18. Let x be a discrete random variable with x as np. The mean and standard deviation of this distribution are equal. So the mean and standard deviation. So np, that's the mean. The standard deviation is, square root np 1 minus p. Okay, so we get n squared p squared when I square the other side is equal to np 1 minus p. Bring it all to the one side. Actually I'll show you everything. So n squared p squared minus np 1 minus p. So we can take out np as a common factor, and we get np, so that's gone, and then minus 1 minus p equals 0. So here we get np equals 0, which it can't. Np minus 1 plus p equals 0. So I'm going to take out a p. I'm going to bring the 1 to the other side. And then I'm going to have n plus 1. So p is equal to 1 on n plus 1. The smallest number of trials so that p is less than 0.01. So 1 on n plus 1 is less than 0.01 or equal to. Let's switch those. So I get 1 on 0.01 is less than n plus 1. 1, how many 0.01s is 100? And then if I subtract 1, I get n is greater than or equal to 99. So the smallest number of trials, and it's equal to, so we know we can include 99, so it's 99. Okay, probability density function is given by this. Cos x plus 1 between k and k plus 1. Okay, so the integral will go from y to y plus 1, cos x plus 1 dx equals 1. And we want to solve for y. Okay, but we know that y is between 0 and 2. So we say given 0 is less than okay, pi on 2 minus a half, which is d. Don't forget to put your restraints in so that you can solve it easily. Okay, this function from 0 to pi on 2, cos x and root through sine x, as shown below. The graph intersects at b, so let's find what that is. What have we got? Cos x equals root 3 sine x. So if we divide the cos across and divide the 1 on 3 across, we get tan x equals 1 on root 3. 1, 2, root 3, so tan's got to be pi on 6. Okay, so we can put pi on 6 into cos. So we're doing cos of pi on 6. Pi divided by 6. Root 3 on 2. I don't know why I just did that, but so that's pi on 2. So I say a half times pi on 2 times root 3 on 2. That's going to give me root 3 pi on 8. That's the area of that. And then we want to integrate root 3 sine x from 0 to pi on 6. So root 3, 0 to pi divided by 6, root 3 sine x dx, plus from pi on 6 to pi on 2, cos x dx. Okay, so that's root 3 minus 1. So the ratio of the area of the shaded region to the triangle, area of the triangle. So we've got root 3 minus 1 to root 3 pi on 8, because we just worked that out there. So it's going to be B, assuming we haven't stuffed anything up. Okay, so we've done 20. 20 was B, 19 D, 18 D, 17 D, 16 C, 15 B, 14 D, 13 E, 12 C, 11 D, 10 D, 9 A, 8 A, 7 B, 6 C, 5 A, 4 E, 3 C, what number is that? 2 D, 1 C. Okay, so that's multiple choice. So I'll have a crack at long answer, what do you call it, extended response soon. Hope this helps. Bye. Oh, don't forget to like, share, subscribe, and turn the bell, the notifications. Share it with your friends. Help them do well in the exams. Bye.